Okay. So this is the WebSphere MQ 7.0 course content. So it will take 30 hours of duration if you take continuously, but sometimes it will extend also more than 30 hours because it is the basics of WebSphere MQ. So now the market has been introduced 7.1, 7.5, even MQ 8.0 has been introduced. So once I complete this 7.0 course, then I will has to extend for the 7.1 and 7.5, even 8.0 I have to explain. So there are some features has been added to the new versions. So including the 7.0, I have to explain for the new versions of the MQ. So during this MQ 7.0 course, so I am going to be cover these other topics. So basics information and MQ overview and messages overview, message parts, MQ installation, and Windows and Linux system I will show you. I will use the Sun Solaris and HP UX. For the IBM UX also I will use the steps, but as I don't have the machine to install and show you, so for Windows and Linux I will show you the installation part. Even this part, migration, file system, MQ objects overview, and it means queue manager, channels, processes. So all the objects I will explain. At the same time, we have the MQ level. There are three types of commands mainly, but the control command and MQSC commands we will use as a MQ administrator. But PCF commands will use by the application programmer. So it's need not to be worry about the PCF command. We will work on the MQSC commands and control commands. And I will explain about the MQI calls. So these are the multiple MQI calls which your application uses to connecting the queue manager, either put or get the message. So these are the MQI calls need to be explained. And there are so many communication methods we have, like DQM, distributed queue method, and intercommunication. And intercommunication and DQM is same. And I will explain about the number of possible connectivity channels, sender receiver, sender requester. There are so many channels we have, so I will explain the channels to make a communication between the one queue manager to another queue manager. And types of channel states. And the next one is multi-hopping and channel triggering. And the channel triggering, we have the two types of triggering. One is application triggering and channel triggering. And I will explain both. And queue manager logging types, settler logging, linear logging, and the other channel types again, the client communication, server communication. So these are the basics and WebSphere MQ 7.0 course. So it will take 30 hours of duration, and I will explain the clustering, the real-time applications. So monitoring tools, what are the monitoring tools we are using for the MQ to monitor. So these will be discussed during 30 hours of MQ course content. So are you looking for these only? Are you looking for any more?
Yeah, I'm looking for these things only. Actually, what exactly will be performing in the environment where I'm looking for all those things.
Okay, you are looking at all these things. Okay.
Yeah. Apart from this, are we doing in the production environment?
Okay. Can you speak loudly? I could not able to hear you, your voice.
Apart from these topics, are we supporting anything else in the production environment?
I will show you what are the real time issues we are facing. So how do you troubleshoot them? And if you need any real time scenarios, I will explain all the things. I think you are already working, right? So I don't want to give you those information. I think already you are working, so you know how to get the alerts. So what are the different types of instant tickets? So those information actually will give it to the who want to go for the phase experience or something like that.
That's okay. I'm asking about there is this document doesn't showing like troubleshooting issues, something, right? If you cover that as well, I think.
Yeah, I think the end of that troubleshooting will be there. So during our course, actually, we will troubleshoot everything.
Yeah. Okay.
during our course actually we will troubleshoot so many issues actually, so that it's not required to mandate to put a troubleshooting concept. Every time we will face some issue while doing something. So either intercommunication or multi-hopping or so many issues we will face during our course actually, so that it will be cover even troubleshooting part also while practicing the things and all.
Okay.
Okay. I just give a small demo about the WebSphere MQ. So it will give you some brief about the what is MQs, what are advantages of why we are going for WebSphere MQ and all. So this is the session agenda. So if you see what is the middleware, what is MOM, so what, why, where, how WebSphere MQ will be used, and the message overview, MQ objects and communication topology, and the file system of MQ and Windows and Unix system, and MQ calls, MQ commands, logs, support packs, and summary and questions. So this is about the session agenda. Today I am going to be discussed. And what is the middleware? A middleware is a software that assists an application to interact or communicate with other applications, network, hardware, or any operating system. So this is about the middleware. So MQ is a message-oriented middleware. It is a IBM implementation of the MOM tool. So message-oriented middleware tool. So message-oriented mainly they have introduced for the to providing the asynchronous supporting. To mainly providing the asynchronous asynchronous messaging to one application to another application, or one component to the another component. So this is about the message-oriented middleware. It is the IBM implementation of the message-oriented middleware. So it means application doesn't talk each other. So MQ through application will talk each other. So here MQ is the interface to one application to the another application. So here application will sending the request. Those sending request will be called as a messages. A message is a string of bytes. It contains some meaningful information which is used to communicate one business application to the another business application. So this is about brief about the message-oriented middleware applications. So there are so many there are so many MOM tools, which are one of the tools is IBM MQ series. So you can see some other tools also, Sun JMS, Microsoft MS MQ, Active MQ, TIPCO, Red Hat MQ. There are so many other message-oriented middlewares already. So why apart from that, why we are going for only IBM MQ series means there are so many advantages and disadvantages between the MQ and the other below applications. So those will be discussed in the next slide. Here the MOM, the mainly we are providing the features is message queuing and publish subscribe, means one-to-one and one-to-many. So these are the communication mechanisms. So these all MOM will be provided. So what is the advantage of WebSphere MQ? So why we are going for the only WebSphere MQ? So this is actually mainly the IBM product. So as you know, so this will be calling as a MQ. This simple term as a MQ. So instead of calling IBM WebSphere MQ, so simply we will call as a MQ tool, message queuing tool. So it was introduced in 1992 in IBM. So after they brought into the WebSphere family, so they will be calling as a IBM WebSphere MQ. So this is the main application which is used to integrate any business application to any business application. The main advantage of WebSphere MQ is it can be deployed and it can be run in any operating system. So IBM is confirmed that more than 85 operating system it can be deployed. It can run on any operating system to interact to any business application to any business application. Okay. So main program which can be used for to make a communication, program to program communication. I have an application which is Java application. It wants to communicate to some different application, that is something like a network application. So even network application which is internally they are using C application, C. So mostly network applications can be run into the C programming. But Java wanted to the C program. So Java is a object-oriented programming language, C is structure-oriented programming language. So still they want to communicate each other. So how the communication will be happen? So if you don't have any MQ series or MQ component, so then how you make a communication? I have to develop one interface to make a Java to C programming language, right? So that interface has to be developed for the every program, means each and every programming language. I have only simple Java and C language, so I'm going to be develop the new interface. If I have like that, there are multiple programming language they want to communicate each other. I cannot develop two different adapters or two different interfaces to make communication to the one program to another program. It is a development risky. It is a development overhead and development cost also. So it is almost IBM, and they have a survey. They told that 80% of the money they are using for to develop the interfaces. Right? So instead of using our own adapter, if you go for the WebSphere MQ as an interface, you need not to develop any kind of adapter to make a communication to the one business application another application. So MQ itself is one adapter, so that the development task will be reduced if you are using a WebSphere MQ series to make a communication to the one Java application to the another Java application, or one Java to any other programming language, C to C, C to Java, C to C++. You need not to prepare any kind of adapters to make a communication. So MQ itself, it is a one adapter, so it is a universal adapter. It's not for the one program to another program. It is a universal programming language. It is a universal programming interface to make a communication to the any programming to any program. So this is advantage of the WebSphere MQ. So it is a universal programming interface. It is not for Java, it is not for C program, it is not for any .NET application. So it can be integrated to the any business application to the any business application. So if you are using WebSphere MQ as interface, you need not to develop any adapters. So MQ itself is a good adapter. It is providing the communication to the any program to the any program. So you got it?
Okay. One more thing. Can you then what is the advantage of DataPower? DataPower also will be the same concept, or it will be like a adapter, or it's something else?
DataPower is actually a message broker kind of thing. So it will transform and it will enrich, but MQ will not do this kind of data manipulation. So MQ only simply the transport layer. So whatever the business application or front-end application is sending, the same message will be transferred to the destination application. But in between, if anybody is looking for some different kind of message, it means like A application is sending some request, B application doesn't know whatever the format of the sender application. He will read only the COBOL application. But A is sending the XML message, but its destination application doesn't know the XML. It cannot able to read that XML message. It understands only that some kind of different ASCII format, message format. So MQ will not do any changes to it is understandable to the destination application. Simply blindly it will send from one business application to another application. That's it. But here we have the ESBs. So MQ it's not a ESB. Message broker and DataPower is the ESB tools. So it will does the message broker will does the message transformation, message enrichment, message routing. So it means it can be converted to the understandable to the destination application. So even MBA also, even DataPower also, same kind of performance, same kind of features will be done. So message broker is a software, DataPower is a hardware tool, hardware device. The performance wise is DataPower is much better than the MB message broker, because it is a hardware, right? Hardware compared to the software it will be the more performance. It can send within seconds millions of records, but MB does not do this much fast.
In that case,
yeah.
Of DataPower, we can send the messages as well. Right?
Hello.
In the sense, with the help of DataPower, whatever MQ is doing, the same thing will be done with the help of DataPower.
No. Mainly the competitor message MQ is the DataPower is not competitor for the MQ. The DataPower is the competitor for the message broker. So if my intention is, I am simply explaining, the MQ will not do any kind of data changes. in between. Okay, if I want to data change, I am sending a some ASCII format, I am sending a XML format message which is understandable to the destination application. Sometimes this XML is not understandable by the destination application. What I have to do, I need one broker. I need one broker to do the changes which can understandable to the other business application. So here the message broker will do the changes and accordingly it will send to destination application understandable language. Same kind of activity is done by the even DataPower also. DataPower mainly it can providing the security not only for the transferring, not only for the message transformation enrichment. It can be deployed in DMZ. So it means like it can be deployed in the security zone, insecurity zone also. But MB if you want to put in insecurity zone, so there can be even hack also some other users. So but when you are going for the insecure network, the DataPower is providing the security. Not only for the message transformation, it can be used for the security also. But anyway, if I want to transfer the data, so either MB or DataPower, it needs a MQ.
Okay.
To transfer the request, either you have to go for the web service call. But if I want to suggest only MQ means, if you want so many features, right, like asynchronous messaging support, they want to store the message in queue. There are so many other advantages. If you want to go for the other feature, then I will suggest for the MQ. No, I don't want to store any data. Even I lost message also, I don't have any bother. Then I will go for the web service call.
Okay.
Yeah. So this is a small example. If you see here, A is in a business application sending a message to the queue. So queue is listening by the B application. B is picking the messages and send reply back to some different application. At the same time, the reply queue is listening by the A application. A is picking the reply message and it is processing. So this is actually point-to-point communication. So here the two business systems are running in two different places. So A is running in some mission, B is running in some different mission. So I am making a communication between A to B using the MQ. So using the MQ I am making the communications, and MQ to MQ how the communication will be happen over the channels. So I have to configure the sender and receiver channels in between the one MQ to another MQ. So I have to create some objects. Those objects will be discussed next slide. So those objects need to be communicate each other. Then application will talk to the objects, and objects will talk each other, and finally it will reach to the message will reach to destination. The destination application's local queue. So there the destination application will pick the message and it will process the communication. So here application cannot directly each other. They will talk. Cannot talk each other. So we are making a communication over the MQ to MQ communication. So MQ will talk each other. So finally our objective is application has to be send a message, so that B application has to receive the message, and they have to process your request, and they have to send reply back to the caller application. So this can be done over the MQ. So MQ to MQ communication will be happen. So indirectly application A will talk to the application B using the MQ. So your programs will communicate to another program using the MQ communication. So how the communication will be happen over the network? So these are the transport types. These are the protocols we use to make a communication. TCP/IP or SNA or SPX. There are some other tools also, other transport types also we have to make a communication. Okay. So what is a message queuing? It means actually the messaging is nothing but to sending a messages to one program to another program. So using the messages, program A will talk to the program B. So this is actually messaging. So it means we are sending a message to the particular storage to store the message. So once the program is reached to the particular destination, it will be the destination is the message storage. It is a queue. The queue is either application, sender application putting message or getting the message. So that functionality is nothing but a queuing. The message will be the putting into the sequential manner. Message will be the putting into the application is putting into the sequential manner. Those messages will be getting by the or listening by some other application to receive the message. So this is called actually the message queuing. So means application A is sending message to the queue. The message will be storing into the sequential manner one by one. So the other destination application will pick those messages and it will process accordingly. So this is called actually the message queuing. So it means application, the programs are communicating to the MQ. So messages are sequentially putting into the queue. Those messages will be either putting or getting the message. This is called actually queuing. Okay, so this is actually the message queuing. The sequentially putting message into queue, those messages will be processed by the destination application. So this is called actually message queuing. So here the message is the it is a request. So this request, using this request, so application will talk to the another application. Instead of direct communication, instead of direct coupling, so we are using as MQ as interface. So using this message, application A will talk to the another application, or one application will talk to the another application. Instead of directly communicating each other, we are making a communication using by sending the request. We are sending the request. So using this request, application A will talk to the another application, or one program will talk to another program. So this is called actually messaging and queuing. So instead of calling each other, we are sending the messages. That message will talk to the one program to another program. So this message will be sequentially putting into the queue is nothing but a queuing. Queuing is sequentially we are keeping the data into the one store place. So the store place is nothing but a queue. If you see, there are so many advantages of WebSphere MQ. I forgot to put two. The first advantage is common application programming interface. As I told you first, here you need not to prepare any adapter to make a communication one program to another program. So MQ itself is an adapter, so that using the MQ adapter we can able to make a communication any program to any program. The second advantage is assured message delivery. So we are giving the assurance. When I am sending a request one business to another business application, okay, I have to give the assurance. So MQ is providing the assurance. Your message nowhere will be lost. Your message nowhere lost. So this is assurance. We are providing the assurance. When you are going for the web service call, when you are sending a request from one place to another place, okay. So in case destination application is not available, that web service call will be failed, right? So if the destination application is not available, so simply it will throw an exception, the page not found or something different exception or service is not available. So those kind of exceptions will be thrown. But MQ, so at the same time, in a web service call, your request will be failed. So again, we have to initiate new request, right? But MQ, your request will not be lost. Your message will be safely, it will be storing into the queue. Until unless your B application is pick that message, or destination application will pick that message and it will process. Okay, we are providing the assurance. Next one is time independent processing. Time independent processing. A is running in the some India, B application is running in some UK. Even to different time zones. So even though we are able to communicate each other, so MQ will be make a communication to the even different time zones also. The communication will be happen. The next one is application parallelism. So here application parallelism is nothing but a, so one application can communicate to the other multiple application parallelly. So I am sending a request. So to verify the account details, okay, I want to know the account information. When it is reaching to the one destination application, it has to send to the multiple backends, whether the multiple business applications, which are the different business applications. So one request will be divided, and this one request will be sent to the multiple backends to verify all the places your account information. Okay. Once all the places your account information is confirmed, you will get single reply to the caller. Okay. So it means one request is dividing into the multiple places. Okay. So for example, I will give some example. I want to travel some UK or US for some time. So we have so many online websites to book the facility, to book the air, to book the like to make a reservation to travel there actually. Okay, over the flight. So for example, Go IBM is there. Go IBM is a web application where you can book the flight information or whatever it may be. So there I am booking the flight from India to UK. So there at the same time in UK I want to travel some places. I want to stay for in hotel. So those information also it can be available in the same website, right? So when you enter all this information, flight information, hotel information, and transport information, okay, but you are entering into the same web page. When you enter the same web page, the same information, so and so dates, so and so hotel, so and so transporter, so everything will be entered into the same place. But the request will be dividing into the multiple backends, the multiple places, because the airport information means flight information will go to the flight database. You are looking for something Indian Airlines, so it will go to the Indian Airlines request. Hotel information, it will go to the particular hotel. If it is transportation, it will go to the particular transportation, right? So when you are entering a one request, the request will be dividing in the backend. It will go to the multiple places. So again, the request will be moved over the MQ only. Over the MQ only. The request will be dividing into the multiple three other requests. All three other requests will be processed all the places, and you will get the success response to the single web page again. So your request has been confirmed like that. Okay. So it means this is one application is parallelly communicating to the other different application. So this is called as well application parallelism. Next one is faster application development. So why we are calling it a faster application development is, so I have a Java application, Java wanted to communicate C++. So Java to C++, I have to develop an adapter. But here, if you are using as MQ is an adapter, you need not to prepare any adapters to make a communication. MQ itself is an adapter, so that using MQ, it can be possible to make a communication, right? So parallel processing and application parallelism is same. And next one is once and only once delivery. For example, I want to transfer a 1 lakh rupees to the some different account. Okay. So if I am using the MQ call to transfer the request over the network. So when I am using that MQ call, so MQ has to give only once and only once delivery. The same request if he is transferred 2-3 times, what happen here? 2 times 2 lakh rupees will be deducted from my account. It will be credited to the different account, right? So this is the reason MQ will not do any duplication. So MQ it will do only once and only once delivery. It will not deliver the same request multiple times. Okay, so MQ is providing the assurance. MQ is providing the once and only once delivery. The next one is, so MQ is providing the asynchronous synchronous messaging support. So asynchronous is nothing but when A is sending a message to B application. So here B application need not to wait for the A request. It means A and B both not in the sync status, both not in available status, right? Even though the request will be delivered, it will be sitting into the queue. Once the B application is available, it will process the request and send reply back to the A. When sending reply back to the B, then sending reply back to the A application, even A application also need not to wait for the B response. Okay, it means A and B application need not to be in sync state each other. So whenever they have a free time, they can respond back to the either request to either response. This is actually called as asynchronous messaging. But the both application need not to be waiting status. When you are sending a synchronous messaging, it means when I am sending one request from A to B, the both application has to be sync status. Otherwise, it will be failed. I will put some timeout. When I am sending a request, I will wait for only 3 seconds. If within the 3 seconds, if the request is not delivered, your request will be timed out. So this is actually synchronous messaging. So both business applications should be in sync status. There are some advantages message driven processing. So MQ is providing the message driven processing also. It means so whenever you want to start an application, business application from MQ level, I have a business application. So it will be the message will be the transformation will be always in night time. So I cannot put one resource to start an application to pick the message, right? So what I will do, in MQ level we have a triggering facility. Whenever the message flow has started, I want to start one business application. I want to start destination application to pick those messages. So MQ is providing the message driven processing to start an application, to start a channel also. This is called actually the triggering concept. So whenever some specific condition is satisfied, I want to trigger an application. I want to start an application. So there are night time. For example, in my environment, I'm using triggering in night time only, because in night time I don't have any SLA to put the resource to start an application every time. So here I am using MQ. So that MQ level we have a facility called triggering facility to invoke a business application whenever the request reach to your queue, or whenever the requests are reached to the depth level. Means I can put whenever the transactions are more than 100, I want to start an application. So whenever the transactions are more than 1 lakh, I want to start an application. So that you can put your conditions to start an application. So instead of manually going to their application and starting, so in MQ level you can set that a condition, so that MQ level application will be invoked. That is called actually the message driven processing. So the MQ will be used for the message file transfer also. Okay. So instead of using that file transfer, other vendors like WinSCP, secure file transfer, and any other tools, we used to transfer the files, right? So MQ itself is a file transfer. It can be run as a message file transfer also. So it can be support for the any MB2, like any GB. I mean, so it can be support for the whatever the GB you want to transfer the message, so those message will be transferred. So earlier it was restricted, but MQ 7.5 onward, the message file transfer has been introduced and very efficiently. It can be run. It can be transfer any GB of data. So there is no restriction. So earlier we have a restriction. There is one more advantage in MQTT, mean telemetry service. So this is also one of the good advantages in going forward. So I think so it can be used in all the business sectors, all the hospitals. Nowadays they already started using this MQ telemetry service in US are big already rich and advanced countries. So they are using MQ telemetry service also. So this MQ telemetry is a lightweight protocol. So even the Facebook also they are using this kind of MQ telemetry service. So this is a lightweight protocol. So it can be used for the limited bandwidth of internet connection. So where we have the limited bandwidth. So there also we can able to use the messaging, chatting kind of things. So this can be used using MQ telemetry service only. So these are the advantages of the WebSphere MQ. So any doubts here? Hello?
Yeah, I'm there. I'm okay.
Okay. Okay. There are what is the message? I told you the message is string of bytes. It contains a meaningful information which is used to make a communication one program to another program. So the messages are 4 types of messages we are using MQ level: the request, reply, datagram, and event or report. Okay. So the request is a sample. For example, request is we are requesting something to the some service provider. That is the request message. Reply, the service provider will process your request and send reply back to the caller. That is reply. Datagram is nothing but it is an update statement. So datagram cannot expect any reply. It will just update the information. That is datagram. The event or report. In application level, we will use the COA, COD, confirmation arrival, confirmation delivery. So whenever the request is reached to the queue, in queue may has to be prepared one COA, confirmation arrival. Once your request has been processed by the destination application, it has to send reply back to the COD. It means confirmation delivery. So those COA, COD will be generated by the queue manager by setting the application expecting the event. Confirmation delivery, confirmation delivery. As I told you, message is a string of bytes. It contains a meaningful information. So here, the message will be divided into two parts actually. The one is the control information, another one is application data. The control information is nothing but the message descriptor, the message information. So who is putting the data? What is the message type? Request or reply, datagram or event. So what is the persistency? What is the account ID? What is the message ID? What is the correlation ID? What is the message offset ID? What is the reply queue manager? What is the reply queue name? There are so many information will be added to your message. So those information is called as a message descriptor or MQMD. The next one is application data. Application data means it is a normal your request. In XML, if you see name will be there, account name, so amount required. So those fields are nothing but application data. How MQ will talk to the, or how application will talk to the MQ. So there in MQ application level we have to write the MQI calls, because so application level they have to write the MQI call to invoke the MQI interface in queue manager. To invoke the MQ interface in, so MQI is nothing but a message queuing interface. So when you install the WebSphere MQ software, there is our program will be initiated in MQ level, that is the interface, that is called actually MQI, the message queuing interface. To talk to the MQ, you will have to write the MQI calls in application. So those MQI calls are below. The MQ call to connect to the queue manager, MQ disconnect to disconnecting from the queue manager, MQ open, MQ close. Those are all the MQI calls. So these are the supported programming language in MQ level: C, C++, COBOL, Java. There are so many support programming languages will be used. So MQ level, so when you install the MQ software, after installation we have to create the object. Those objects are here: queue manager, queue, topic, channel, listener, process definition, name list. So using these objects, you will communicate to the one program to another program, or one MQ to another MQ. Okay, so these are the MQ objects. Application will talk to the MQI. So MQI will talk to the queue manager. So you under the queue manager, you are able to see these objects, MQ objects. So the main object is called actually queue manager. Queue manager is a runtime component. In WAS, how is the application server? The same thing in MQ. The queue manager is the main component, is a runtime component. So it is used to provide the queuing services to the more than one client. So queuing services is putting message or getting message to the queue level. So MQ series, so queue manager is a runtime component which is the server which is providing the queuing services to the one or more clients. So that is it is a runtime component, it is a main object for the MQ. So under queue manager, queues will be created. So queue is nothing but a storage space where we can store the messages. So these queues will be to put and get the messages from the queue level. The purpose of opening a queue: to open a queue means to put message, or to get message, or to inquire the message depth. So those information will be mainly open for the queue. The application will open a queue either to put or to get the message, right? There are so many types of queues. So local queue, remote queue, transmission queues, initiation queues, dynamic queues, alias queue, dead letter queues, there are so many queues will be existed in MQ level. So each queue will having their own functionality. Okay, so those will be discussed in during the class. There are channels. A channel is a communication path between the one queue manager and another queue manager. When you want to make a communication one mission to another mission, so channels are the main important communication method, communication interfaces. So using the channels, we will make a communication, right? There are so many types of channel types. There are messaging channels and MQA channels. Again, messaging channels will be divided into 2 parts again. So those will be discussed. So these are the messaging channels: sender, receiver, server, requester, requester, sender channel, cluster, receiver channel. The combination channel is sender and receiver, requester and server, requester and sender, server, receiver, cluster, sender channel, cluster, receiver channel. These are the combinations of the channels. I told you 2 types of channel: messaging channel and MQA channel, right? So this is MQA channels. So MQA channels are the two-way piping channels. If you see here, these are the MQA channels will be used. How it will be? There are so many other objects. So these objects will be discussed in the next class. So these are the communication topologies. For example here, so we have to work on these communications like the local communication, inter-communication, client-server communication, hub and spoke mechanism, cluster, multi-hopping, triggering. So these are the communication topologies will be discussed. So in MQ, the path of MQ series in Windows and Unix is, so this is a file system. So product path will be OPT MQM or /user MQM. OPT MQM is for Linux and Sun Server, but AX system is /user MQM. So the working directory is /var MQM is for the all the Unix flavors. The product path will be different for the AX and bash bash. Here OPT MQM is the where Linux and Sun Server is, AX will be the /user MQM. The Windows, the path will be the same. The root path is C program file IBM MQ. So the logs are again different types of logs are available in MQ level. Those logs will be discussed here. The var MQM log, it is a transmission log, it is a transaction log, and error log. The /var MQM working directory log, that is okay, transaction log. In Windows, C program file IBM MQ log. But when it is in Unix, /var MQM is the log directory. And error directories also will be available in MQ. There are 2 types of error log: MQ series level error log and Q manager level error log. The path is /var MQM error. This is the MQ series level error log. /var MQM QMGRS, particular Q manager name and error. This is the Q manager level error logs. So in case any issue you are facing, you need to read the error log to sort out the issue. There are some sample reason codes actually will use. So to identify the issue, so when you are facing an application is facing some issue, so they will get the MQ reason code. So by reading the MQ reason code, you will troubleshoot the issue accordingly. So few reason codes will day to day you will see these: 2033 timeout, 2035 not authorized, 2085 unknown object or object not found, 2009 connection broken, 2059 Q manager not available, 2058 Q manager name error, 2053 Q full condition. So these are the sample reason codes. So we'll use support packs also for MQ easy administration. So these are the support packs will be used to put the message, to get the message, to take the backup of the messages, to load the message, to unload the messages, for browsing purpose, taking the backup of the MQ objects and Q manager objects, to monitoring purpose, for RFI utility to put the message, to get the message, the graphical tool. So these are the so many support packs will be used for easy administration. So this is about the MQ demo. So understand, Balaji?
Yeah, Ram, for sending the messages, the MQ will be installed in the both sides, right? Both missions.
Yeah, both missions. See, based on your architecture, so sometimes they will request MQ client software also. There are 2 types of software that are available: MQ client and MQ server. Using MQ client also, you can able to get the message, but it doesn't have the storage. MQ client, but MQ client finally it has to communicate to the either Q manager only.
Only queue manager, not either. It should communicate to the queue manager. So it means whatever your is correct, I tell you have to install MQ, the both places.
Okay.
If I have only small Java application, I want to get the message from the somewhere. So I cannot install MQ software here, MQ server software. So MQ server software is expensive software. So I cannot install for the one or two application where it is running. So I will use, if the requirement is, if the revenue purpose also have to take care. I have to think actually. Management overhead, management task also I have to think. So in this reason I cannot install wherever applications, small applications are running. I cannot install MQ software. I will use MQ client software to put that to get the message. So you mean to say the every place MQ should be required to put to get the message.
Okay.
Yeah, both places MQ is mandatory to put the to get the message.
Okay.
Okay. So this is Balaji demo.